Welcome to Algebra Chapter 8, Lesson 1. This lesson is all about, you guessed it, large numbers. Although I don't mean large like this, although it's awfully cute, but large like this. We don't generally see $390 million or $3,900,000,000. Those zeros are very significant zeros when they come at the end of a number, right? Zeros are also significant when they come on your test too, I realize. But this lesson you're going to see that we refer to numbers in scientific notation. If we had $390 million, we could rewrite it as 3.9 times 10 to the 8th, because if you could see, we moved 1, 2, 3, 4, 5, 6, 7, 8 places to the left to put our decimal in between the 3.9. We would have 8 places that we had moved over. We're going to be dealing with powers of 10 as well. And basically, if you have 10 squared, it's the power of 10. It would be 10 times 10, which is equal to 100. 10 cubed, 10 times 10 times 10 is 10 to the 1,000. If you think of it as the exponent, when you have a base of 10, simply determining how many zeros you have in your final number, okay? That's an easy way to remember what a number looks like when it's a power of 10. We're dealing with scientific notation as well. And what you need to understand, probably the most significant thing and the things that students make the most problems about, are failing to put things in proper scientific notation form. Your form should be a times 10 to the b, okay, where this is your power of 10, 10 to some sort of exponent. Okay, the number a should be equal to or larger than 1, but it has to be less than 10. It's just a single digit. Now, it can be a 0.3 or anything like that, 9.342, and go on and on and on forever. But the point is that only one number is to the left of the decimal, and you have to have one number to the left of the decimal. So if you had 0.3 times 10 cubed, it would not be in proper scientific notation form. You would need to move that decimal over to the right and make it 3 times, and because you've made this small number bigger, you're going to make this exponent smaller by 1. But we'll be talking about that quite a bit. But that is the basic rule. It's very important. Your book's going to ask you to create numbers or write numbers that are 10 times as large. Sometimes it will ask you to do 100 times as large. If you did a number that was 10 times as large as 3,400, you could write it in decimal form like that, okay? 34,000. If you had a number that was written as 5.72, to write it 10 times as large, you could write it as 57.2. If it's in base of 10, you could say 10 to the 8th is simply 10 to the 9th. Keep that nice and easy. And then, of course, if you had, our last example here, if you had 8 times 10 to the 6th, then you could simply change the exponent when you're doing scientific notation. You're going to run into those kinds of problems, and they're not really that difficult. You'll also run into problems where they want numbers that are 1/10 as large. So if you had 750, you would basically move the decimal to the left and make your number 75. If you had 2.8, you're going to make that number even smaller, moving that decimal so that you have 0.28. Is that 0 necessary? No, not to be correct, but it makes it really clear that you do have a decimal in front of it, because most people don't write 0, 10, and things like that unless they have a decimal. If you have 10 to the 6th, you would simply write it as 10 to the 5th. If you had 41 times 10 to the 9th, because it's not in proper scientific notation form, you can actually just change the 41 to 4.1, which is making it a 10th as large, and you don't have to change the exponent in that at all. Sorry, you couldn't even see that, could you? So if you had 41 times 10 to the 9th, you can make it simply 4.1 times 10 to the 9th. If you're writing numbers in scientific notation form, let's say you had the number 1,984. You can pretend that there is a decimal point at the end of every whole number. And so if you have to put it in scientific notation form, knowing that you can only have one number to the left of the decimal, you would move this created decimal point 3 places, and you would just put it here. You'd end up with 1.984, and because you had to move this 3 places, you would have 10 to the third. Okay, if you had 940 times 10 to the 8th, and they said for you to write it in proper scientific notation form, and they won't be putting in write it in proper scientific notation form. Don't be thrown off by looking at this and saying, oh, it's already in scientific notation. It's not acceptable. We have to have a standard so that everybody's doing it the same way. So again, pretend you have a decimal that you can see. Move that decimal 2 places to the left. When you make a big number smaller, which is what you're doing when you make 940 simply 9.4, then you're going to make the exponent that many times larger. Okay, so we move 2 times here, so we're going to make this exponent 2 times larger. It's actually 100 times larger, but if you add 2 to 8, you'll see that it's 10, and that's what we're referring to. If you're asked to write something in decimal form, you're just simply writing the number in the form that you're used to seeing. So if you saw 2 times 10 to the third, you would simply add 3 zeros to the 2. That's not so hard. If you had 0.0084 times 10 to the 7th, then you're going to have to actually move that decimal 7 places to the right. 1, 2, 3, 4, and then 5, 6, 7. So you're going to have the 8 and the 4. You don't have to write these zeros that came before it, but you do have to add these 3 little loops that you have found. And so you would end up with 84,000. And that's pretty much all there is to the large numbers that you're doing in Chapter 8, Lesson 1. Have a great day.